welcome to the next module which is on remote sensing. This is lecture 13 and in this lecture we will give you the brief introduction of remote sensing, what it is and what it can do as far as the application part is concerned. So, let us begin this lecture. Remote sensing we are defining as the art and science of acquiring the information about the earth surface from a distance. So, remote is a distance and sensing means the feeling. So, if we feel something from a distance, if we capture the data from a distance, so that is called remote sensing. So, here mostly we are away from the earth and there are satellites up in the sky which are launched and continuously they are taking the picture of images of the landscape, global field and plant area. So, from global to a local level they are collecting the information at different scale. So, in remote sensing we acquire that information in digital mode and then we are extracting the useful information from that information from the data which has been acquired by remote sensing satellites. What is the role of remote sensing? It will provide us the images of the earth surface in space and time. Meaning of that is the whole of the earth will be covered and at different time interval we can get the information of the earth again. That is the biggest advantage of remote sensing, because when we are dealing with the photogrammetry we have to fly to the area, take the images of that area again, and that becomes a very costly affair. But here once the satellites are launched, they are continuously giving us those images after a regular interval of time. So, we get space and time data and we are getting continuous images also of the area, so that we can do the monitoring and mapping of the earth surface. Now, it is also important, we do not require a static map, we require a map which shows the changes in the area which has taken place over a period of time. We require updated map. So, map which has been prepared today may become outdated in few days, in few months time, because of the developmental activities which are taking place on the earth surface. So, we have to monitor those earth resources. So, in order to carry out that monitoring part, there are certain activities also, flood, earthquake, which are sudden in nature and will change the entire landscape. We require continuous images. So, these images are helping us in mapping and monitoring. Remote sensing data provides very efficient, very accurate and cost effective method, because once the satellite is launched, for its whole life now you are getting those images of the area. So, analysis of that is digital. So, this has become very efficient, and as far as the accuracy is concerned, you do not have that kind of a problem which you feel in aerial photogrammetry, the more distortion at the edges. So, our data is more accurate and its processing is efficient and you are getting very cost effective analysis from these data. Now, there is an ideal image of the remote sensing system, how that remote sensing system should be there in reality. So, although there is nothing like ideal on this earth, but ideally if we have to define the best remote sensing system, so then there are four major components of this remote sensing system, and these are a uniform energy source. The first one is a uniform energy source should be there, which should provide us constant energy over all wavelength at a known rate. So, that means that if I draw a curve between the wavelength and the energy, so this is a horizontal line, because I will get the constant energy even if I am changing the wavelength, and the rate of change should also be known to me, and I should get the high level of output irrespective of the time and place, whether it is morning 10 a.m. or it is afternoon 4 p.m. or whether I am standing in Delhi or I am standing in Chennai. So, irrespective of the place, it basically will give me the that constant amount of the energy at all the wavelengths. So, here uniform energy source does not exist, and we are dependent on the sunlight. So, sun is our source of energy which can illuminate the object on the earth. Non interfering atmosphere, the second one is non interfering atmosphere. We know in the atmosphere there are pollutants, there are gases. So, we have different molecules, particles, H2O, which are present in the atmosphere, ozone for example, oxygen, and this what happens is because of that they are interfering the energy which is travelling from the sun to the object on the earth. So, we require in an ideal remote sensing system non interfering atmosphere. So, the entire energy should reach from source to the object. There should not be any loss of energy, that is the meaning of that, where the energy which is transmitting from the source and emitted or reflected from the object, because each object is also emitting the energy and reflecting it, and that is why we are able to see that. So, any object, let us say the energy is striking to that, it is emitting its own energy and we are able to see the reflected energy from that. So, there should not be any loss of energy when the energy interacting or travelling in the atmosphere, that is the meaning of non interfering atmosphere. The next part of it is third is the reflected or emitted signals which are generated from the objects present at the earth surface are selective with respect to wavelength and also unique to each object. That means that the object which is reflecting the energy or emitting its own energy have its own characteristics. It is distinct. So, each object has a distinct characteristics to reflect and emit its own energy, and because of this distinctness we are able to differentiate. We can see the color of the object, we can see the brightness of the object because the reflected energy which is reaching to, let us say, our eye is different. I can see the table as brown, I can see the tree as green because the different amount of electromagnetic energy which is reaching to our eye. Then the last category is super sensor. Now, this super sensor, like in human body, the super sensor could be the eye where all the reflected radiations are reaching. So, similarly we should have a sensor, like in aerial photogrammetry we have camera system. So, here we have a sensor and we call it a super sensor because it is simple, it is reliable, it is accurate and it is economical and also highly sensitive to wavelength. So, as the wavelength is changing, it shows a sensitivity to capture that reflected radiation. So, sensor will yield absolute brightness from a scene as a function of the wavelength. So, here the curve between the wavelength and the brightness of the object could be a zigzag curve, because the every object will behave differently, will reflect differently. So, it cannot be a uniform source, it will be a kind of a varying kind of a source. So, if you see the diagram of it, the uniform source of energy here, the wavelength and energy, it is depicted by a straight line here. So, energy is uniform at all the wavelengths. So, when you change the wavelength, the energy remains same. But if you change the wavelength here, the radiance which is coming from the object which is captured by the super sensor, now this curve is varying because the amount of energy now is captured is different. Now the second part is this atmosphere here, which is a non interfering atmosphere, no loss of energy. So energy is travelling from source reaching to the earth. There are various objects on the earth surface. So it is reaching without any loss, and then from the object the energy is either reflected or emitting its own energy, and it is captured by the supersensor. So these are the four ideal elements of remote sensing systems. So if we understand in more detail now what are the processes, different processes which are taking place, there are several processes which are explained with the help of the diagram here. Number one is, and the foremost and most important here, is the energy source. So we have the energy source of illumination, which is a sunlight. So we are using the sunlight to illuminate the object on the earth surface. Then the second part is the radiation and the atmosphere part, which comes into being. Third is the interaction with the object. Next is the energy which is recorded by the sensor, and transmission and processing part is the next one, which is done at the ground receiving station. Interpretation and analysis is done at F, and the application is done at the G part. So let us see these parts, each and every part now in little more detail. So we have several processes and several systems, and they are called 7 elements of remote sensing, popularly known as 7 elements. So the first and foremost important element is the sun energy. We have to illuminate the object, and we have the natural source of illumination as the sun. So in daylight, these remote sensing satellites mostly will use this capability of the sun to illuminate the earth's surface. So sun energy, which is the electromagnetic energy generating, we are using that. Coming to B, which is the atmosphere. So when the rays are travelling from sun to the object, there is a intervening atmosphere. So the atmosphere will intervene with the incident ray. It will also intervene with the reflected ray. So when the ray will travel back also, then atmosphere comes back. So incident ray, reflected or emitted ray, the atmosphere will interact twice, once incoming and another is outgoing. So here we have various molecule dust particles which are playing its own role, and they are absorbing some of the energy, they are actually scattering some of this energy, and rest of the energy will reach to the sensor part. So scattering and absorption we will learn in subsequent lecture. Third part is the object. Now the object on the earth surface, they are also very important to us, because now when the energy is falling onto the object, we have various kinds of objects with different shapes, with different size, with different orientation, with different material, with different composition, with different height. So each object will behave differently with this electromagnetic radiations. So when the incoming radiation will strike to the ground, interact with the object depending upon the physical and chemical property of the object, the constituents of the object, this will actually behave. So we will learn more what is happening at this point, at point C where the object is present. Then the next part is the sensor part, very important part, because the sensor has to record the energy now which is coming back to the reflected back from the object to the sensor, or emitted energy by the object itself. So both the energies will be captured by the sensors, and the sensor, this energy is converted into digital signals, and these digital signals are very useful to us to carry out the interpretation, to carry out the measurements from those images. So there are various types of sensors nowadays. There are sensors which can operate in the night time, in the daytime also, and the night time also. We will discuss later those parts. Then the next component is the transmission and reception. So this is our E part, which is transmission, reception and processing the data. So when the satellite is up in the sky, it will capture the incoming, the reflected and emitted radiation, and then it will be transmitted back to the station, the ground receiving station. So there is a ground receiving station in almost every country. There is a ground receiving station, but the country which is launching the satellite will have the ground receiving station, and the data would be transmitted to the ground receiving station. So ground receiving station will actually collect all this data and carry out certain processing part. So certain errors are there, inherent errors are there, which are removed, and then this data later on goes to the component F. So component F is the interpretation and analysis part of it, which is the user part. So user will acquire that data and carry out the interpretation and analysis part. So this part is quite important to all of us from the user point of view, that once we acquire this data, once we get this data, then how to carry out interpretation, how to prepare the maps, how to carry out the measurements, and how to use these results for some application purpose. So that is my F part, and last is the application part. So my result should be useful for certain applications. So there are again large number of applications of the remote sensing data. So I have some specific application in my mind for which I am carrying out the analysis, extracting the information. So I try to implement that information on the ground through my applications. So here you can see that this is a data acquisition process. The data is transmitted to the ground. This is the satellite which is collecting the data and transmitting the data at ground receiving station. And at the ground receiving station, when the data is transmitted, it is processed and it is archived, and it is ready for distribution. Because the data is continuous, so data is segmented into small scenes, so that it is easy to handle, and we know how much area is covered by one particular scene. So this is archived, continuously kept in archive and distributed to the user on demand on payment basis. Now when we are talking of the ground receiving station, the data is transmitted to the ground receiving station. You can see that the circles here, the red circles, all are indicating the area covered by a ground receiving station. This is the influence zone, which is ranging between 3000 to 4000 kilometer radius. This is for a particular satellite, which is American satellite Landsat. So you will learn about this Landsat satellite more in subsequent lecture. So this is a very popular American satellite, and these are the different locations of the ground receiving stations, and each of this station will cover a large area onto the ground. And you can see that for India there is a ground receiving station at Hyderabad, at Shadnagar, near Hyderabad in India, and it is again covering between 3000 to 4000 kilometer. So that means when the satellite is moving in the orbit and it is within this influence zone of the ground receiving station, it will transmit the data directly to that ground receiving station. Now little bit about the history of remote sensing, how this remote sensing technology is developed. So if we look at this 1960s and 1970s, the platform was aerial, and during that time the platform is changed from aerial to photogrammetric to satellite platforms. So earlier we were using aerial platforms, and now we are using in remote sensing the satellite based platform, and now we have come back to again aerial platform, with the use of UAV drone systems. Their platforms are at a lower height. So, looking at the developments, how the remote sensing satellite based remote sensing has developed, you can see on the x axis you have lots of satellites. Okay, this list is not complete, this is just the exemplary list. So, it shows some of the American satellites, it shows the French satellite, it shows the Indian satellite, it shows the American satellites, Japanese satellites, and so on. So, it is a very long list. The name of the countries are also given in the diagram here, and you can see the year of launch is 1972 onwards, and then the list continues further. So, that is how the we have shifted from the optical to radar and other microwave data also. So, this development has taken place from 1972 onwards in remote sensing. Some applications, exemplary list is there. Very popular use of this remote sensing data, satellite remote sensing data, was land use and land cover mapping, because this is the base map for very large number of applications related to the earth surface. So, whenever we want to do any developmental activity on the earth surface, we will like to have a land use and the land cover map showing the present, as well as maybe sometimes we require what was the past scenario, what is the change, which particular land use has changed. So, land use and land cover map, which is very important in large number of applications. In fact, the satellite data have been used in a very large basis worldwide. Forestry, agriculture applications, telecommunication, environmental application, hydrology, urban planning, infrastructure, emergency and hazards, global change and meteorology. So, again this is a multidisciplinary kind of a science tool which can be applied to a large number of applications even outside civil engineering domain. Now, the other advantage of this data is that you are getting the data at different resolutions. If you want to cover the whole of the globe, you have the data with you which you can very easily handle. The resolution may not be that good, it may be a kind of a low resolution data, but if you are working on a small area on a local basis, then you have very high resolution data. So, this is we call it the global to local scale application, depending upon our application, depending upon our study area, depending upon the amount of details which we want to extract from this data, we have the data. So, this is our NOAA satellite data which is covering a very large area. You can see the entire globe. This is IRS data, Indian remote sensing satellite data, southern India I am showing you. So, this is covering a moderate amount of the area. Then if you have to prepare a medium scale maps, this is Indian remote sensing data, list 3 data, and this is the panchromatic data where the area covered is very small, but very detailed information. Even the individual house, each and every street, each and every tree can be located on this image. So, it depends on our application, we like to go for the area. This is the land cover map. Suppose we want to carry out climatic change study for the whole world. Suppose we want to know how the forest cover is changing in the entire globe, then we require the data at a low resolution, coarser resolution. So, this is at coarser resolution satellite data, this is the MODIS satellite data, and entire globe is seen now, and you have very broad categories of the land use and land cover map which you can prepare from the satellite image. So, this is the advantage of having those satellite image. Now, you are not creating that kind of a mosaic which has been explained in photogrammetry. Now, this is again a low resolution or a poor resolution data because it is covering a very large area, and you can see the cloud formation on this satellite image and the map of India. So, these cloud formations are there, so seeing the different and the density of the cloud, the shape of the cloud, the color of the cloud, some kind of a meteorological study can be carried out with such kind of a data. This is our medium resolution satellite image, and in this medium resolution satellite image one can see now urban setup. So, this middle part, the blue part which you see here, this is the Jaipur city area, and in the surroundings you can see pink color, pink shade, which is a vegetation cover area. Aravalli Hills on that. So, on a medium resolution data we can see the landscape, we can start feeling the landscape, the higher area, the lower area. We can also see some of the major roads which are present in the area. These linear features are the major roads which are actually coming to the Jaipur city. So, this is the advantage of medium resolution, but as we go for a higher resolution satellite data from our Indian remote sensing satellite, this is a Rajpath area in New Delhi, and one can see this is the Rajpath area and can very well see the octagonal kind of a structure, hexagonal kind of a structure everywhere, these kind of pattern, and the roads are emanating from all directions. So, one can here from this high resolution satellite image, one can carry out infrastructure mapping, one can prepare the maps at 10,000 scale, at 5,000 scale nowadays, which was not possible earlier with the slightly moderate kind of a resolution satellite data or the low resolution satellite data. Now, not only mapping purpose, but administration is also using these high resolution satellite image. For example, in Allahabad in 2001, the Mahakumbh which happened, the entire planning was, this is the Sangam area which you see on the satellite image, for planning the tourist management, how the tourist movement will be managed, where will be the parking space, which of the roads would be one way, which are the two way roads. So, all that planning was done by the administration on high resolution satellite image. Now, classification of the image, this is a kind of a medium resolution satellite image which I am showing you of the lower Himalayan region, where we have Rishikesh here just at the bank of the Ganges river. There you can see the river part here, and there is the Devprayag and Vyasi portion. One can see the river, one can see the hilly pattern which is present in the area. You can see some of the shades also, some of the area is in the shadow. So, using these kind of images, one can actually carry out land use and land cover map. So, this land use and land cover map which you are preparing from the satellite image now can be used for a very large number of applications, because this is that map which is very much beneficial if I am doing, let us say, the planning a new road in the area, or if I am planning some tourist spot, a new tourist spot in the area, this map is required, or if I have to plan the land use in the area, then also this map, and also the change in the land use is required. So, land use and land cover map becomes the basis of very large number of planning and developmental activities. This is a Ganges river. You can see here multi-date satellite image. So, we are many times we are not dealing with a static image, we are dealing with a temporal time frame images. So, this is 1980 image, this is 1990 image, this is a 2000 image, this is 2010 image. So, this is the advantage of satellite image. You can have a previous data, so you can build some kind of a temporal scenario, how the things have changed over a period of time. So, these 4 images are taken for a part of the Ganges river, and one can see actually how the river is behaving and river is changing. So, very clearly if you focus in this particular area, this there was no water in that river was not flowing, there was a very small channel, but if with respect to time you can see the major channel has become on the lower side, and also the shape of the river has changed. So, this change analysis one can carry out if you look at the 2010 image and focus in this area, you can see lot of change which is taking place in this area as well as in that area. So, whenever we have to actually carry out the management of the river flood protections, such images are very useful to carry out the change analysis and identify the critical locations. So, if river morphology has to be studied or study related to flood planning has to be done, then you require temporal images which could be analyzed and studied together. A tsunami which took place in 2004 in our country, you can see here on the left side we have image just before the tsunami. You can see very clearly the island with the lush green kind of a vegetation which is shown on the false color, the pink color, and very clear water. So, one can see very deep water which is a dark blue color, and slightly lighter blue color is shown by the water which is adjacent to the land area. But after tsunami took place 26 December 2004, what happened is you can see the muddy water, you can see that all the island that is covered with the muddy water, damage has been done, water has entered into the island area and created a damage. So, one can compare the two and find out how much is the damage without even visiting the area. So, lot of information can be extracted from these different time frame images. This is mapping the land feature from the satellite image. So, this is a high resolution satellite image, and I will take a small part of this image now and show you the zoomed location. So, I am taking this particular part of this image and showing you after zooming. So, when you zoom that image, now you can see the amount of information, enormous amount of information is present on the image. There are large buildings, there are a small building, there is a highway, this is a highway, several lanes highway, there is an intersection of the road here, and then in the surrounding there are some trees, some open land. So, all that is visible to me, and now if I want to create a map after digitizing the features, maybe the on screen digitization, I will carry out something like that. I can carry out the mapping of those land features, and different colors and different symbols are indicating the different kind of land use and land cover features which are present on the data. So, this is the kind of information which can be extracted straight away from the satellite image, and then this information becomes the input to further analysis, integration of this data along with the other data in the GIS environment. These are the various advantages of using the remote sensing data. It provides bird's eye view, it covers a large area, and we can see inaccessible area, particularly remote areas where you cannot go to collect the information. You have the data right sitting in your office lab. Easy and rapid analysis you can do. Temporal images, time frame images can actually help you in monitoring the area and will give you the past statistics of the area. It saves cost and time in data collection, data analysis when you are comparing it with the ground based methods. Digital, it is the digital data, and the best advantage is that you can enhance the data, you can quickly interpret data with the help of the image processing software. You can integrate this data with GIS based application, which you will learn little later when I explain GIS chapter, and this digital image can be processed to generate new images without altering you can keep your original data safe, and then you can experiment with data and create other transformations to create the digital images. There are some disadvantages too also of this remote sensing data, and one could be the interpretation is not straightforward. It requires certain skills, certain experience, certain knowledge. So that you have to acquire how to extract the correct information from the satellite image. The results which you are deriving from the data sitting in the laboratory, they are to be verified in the field, and at least 10 to 15% ground verification is required in order to assess the accuracy of the results. Now we have lots of images from multiple sensors, and we have to use them together. So we should know what are those pre-processing steps when we are using the data from multiple sources. Then images, sometimes they have cloud cover, so they obscure the ground information. So we should know that how to handle with these kind of images, what are the different approaches to remove the cloud cover, so that we can get some information about the ground below the cloud cover. Now objects can be misclassified also. When you are using digital methods, algorithms, and the algorithms are mostly working on the reflectance pattern basis. What is the reflectance pattern of the object? So sometimes if two different objects have the similar kind of a reflectance, your classification may be wrong. So you have to understand the algorithm and then try to work accordingly, so that you do not have the misclassification from the satellite. So this is all about the, in a nutshell, the introduction of remote sensing.